Hello everyone, and welcome back to a new episode of EXAPUNKS. We just robbed a bank, and I guess now we're gonna go fight someone in a wormhole? If you keep on winning, they'll eventually have to accept that you're back. Yeah, I don't really care. Why not? They seem to care a lot, so don't let them down, okay? Time to win. What's the deal here? You must fill the network's hosts with as many of your X's as you can. Note that each pair of test runs has its own unique network layout with bidirectional links between hosts that use the prime numbers between 2 and 13 as link IDs? Huh. How many X's am I allowed? Is storage limit? Storage limit is 100. Yeah, that's how many I can have. I can have 100 X's here. Oh, how nice. It's all perfectly symmetrical. We play each map twice. Once with me on this side and once with me on this side. To make it fair. Okay. We're playing duplicate here, I guess. So how do we even begin? Like, this seems hard. Ah, I see. So the idea is, once you successfully establish... I was trying to imagine, like, a way to determine the route from here and start spawning new X's from the route that traverse the known route. But that's quite difficult. Instead, whenever you successfully move... you just, like, stay there and make copies of you to explore in other directions. And there's some wasted value by exploring back in the direction that you came from. So you could imagine, like, oh, I crossed over link 11, therefore don't bother going using link 11 when exploring further. But actually it's fine to go back because that just fills up another space, so sure. So we want to go to 800. That gets us onto the network. And then it gets a little trickier, right? And what to do with this file, or not this file, like these prime numbers are not easy to work with. I guess instead of linking to 800, would I do just as well to replicate to 800 so I get more hosts in a known good state right away? Right, like I could just oh, but I don't actually want to fill this place up. Because then we won't have room to replicate. I think I'll just sort of take as granted that when we have a node here, when we occasionally, like, we'll make a copy that goes somewhere else, and like eventually that somewhere else make a copy that goes back here. I don't know. Maybe it'll be faster to fill this up a little bit first, like put 2 nodes here. Yeah, that's an idea, I guess. So REPL init, and we'll just mark init here. Now we have 2 of them that are both getting started, right? He doesn't think of that. I'm too smart. And we'll just mark this as root or something. Like this is what, we'll call it spread. What to do when you have arrived at a node without being killed. And we kind of want to, like, just like for each of these values do something, right? So we want to, like, copy 2 to X, and then REPL to move, basically, right? Mark move to be link X, jump, spread. And then we'll just do the same thing for 2 for each of the prime numbers. So copy 3 by 2 into X, REPL to move, and then we'll do the same thing for 11 and 13. Something like this. So what exactly is going to happen here? We go in. This one makes a copy that says I want to go to 2. And then this one makes a copy that says I want to go to 2. 2 isn't here, so they both die. But this one's already set to explore 3. And finally they discover 11. Oh, and I need to, hang on, stop. I forgot to make these guys go back to the beginning when they're done, right? Replicate to move. And if you didn't do that, oh, actually don't replicate to move, just replicate, I guess that's fine. And then jump back to spread. You've already tested all of the places you could go. Now begin iterating again to spread more. Do we ever get to 13? Oh no, because I did it wrong. It shouldn't be not 7 plus 4, but 11 plus 2. We sort of blocked him in, haven't we? But he owns a large part of the network. I don't know. What's the score? He's winning by a lot. Alright, well, we lost this one by 1. Wow. Okay. And then all this stuff just doesn't do anything. So let's try playing this in reverse. I missed. It went so fast. Yes, this one we're winning 33 to 30. So clearly this is just the better side, and it looks very similar. All right, well, let's just go. How are there some nodes nobody got to? I guess those were because they were attached to him. I'm losing this. $52 to 47. Gotcha. All right. Fine. Well, let's do a quick edit here where we just don't do this part, right? Does making that copy of ourselves actually get us anywhere? We lost by a little bit more in game 1. And in game 2, we lost instead of winning. So that seems like it was a good feature to have. It would be real nice to replicate a bit faster somehow. Like this whole like copy a thing into X and then ignore it a lot of the time is pretty bad. It's really slowing me down. We'll just run this real quick to prove we're still winning. Yeah. But this is efficient, like this is simple, but I think we would do better to just replicate to a place that has exactly the number we want in it. Yeah, I don't need this stupid X. I can just link to or repl to a place that is intended to go to that location. So let's just shut up. I'll read that later. I want to go back to this, please. So what I wanted to do was copy this, and instead of this copy 2 to X, we'll just do things way faster with no registers. Repl to move 2. Okay. And mark move 2 as link to jump spread. Okay. And then we'll do something similar for here. So we'll just repl to move this, and then mark, hang on. I guess we need to do this a little differently. Rep 3 mark move at of 3 and 2 link to at 3 and 2 end, and then we'll repeat to, well, we don't need to do any repeats here. So there's just 2. No, there's 3 states left. Right, go to 11, go to 13, or don't go anywhere. So we'll repeat 2 of repl to move into this place. And then we'll repeat 2 of mark move at 11, 2 link to at 11, 2 and finally jump back to spread if none of that happened. So this should have all of the same effects, but probably with less actual post-macro expansion code. Although maybe not, we wrote a lot more labels. Although I don't think those count. And definitely less shuffling around of values into registers. Oh, they blew up. Okay. So let's just, yeah, REPL 2, move 3. Oh wait, this is not correct. There's lots of things incorrect about this. So how does the move to 2 look? Is it okay? We REPL'd to move 2, but then in both cases we just link to 2. So that's clearly incorrect. We need to REPL to, like, don't move to 2. Yeah, I guess we need to God damn it. We need to have all of the REPLs right in a row, and then all of the marks. So this is going to go down to the bottom. Well, actually it's going to go below this, right? So we have a REPL of move to 3, 5, and 7. And we need this to say jump to spread, right? Now we have a REPL for 11 and 13. We need the marker for this to say jump spread and be at the end here. Mark move. Why does this just say move one, like just move? That doesn't make any sense. I never jumped to move, so let's get rid of this.
Let's go.
Link X? What the fuck is this? Okay, this must have been from an old version or something. So we have a label for, we first try jumping to move 2, then we jump to 3, 5, or 7. Then we jump to 11 or 13. And if none of that happens, then we are the ones who stay in this node, continuing to send out tendrils. Uh-huh. And then we have all these marks. Move 2 is linked to 2. Yeah, this looks okay. Let's try this now. Okay, we might have gotten a little bit more ground from him up here. I'm not sure. What's the score? 33 to 25. Yeah, we got a much better. Oh no, he's got some more copying to do, I guess. 33 to 30. Fine. That's a win's good enough for me, I guess. How about test case 2? Oh yeah. Oh my god. Look at this dominating performance. Why are these guys... Oh, they can't replicate, I see. Yes, this gets empty because neither of us was able to fork off a process in time to go there. And you don't really want to risk just moving one of your existing processes because the other guy might take over. And you're probably just moving into a dead end anyway. Yeah, we clobbered him here. This looks like a loss, though. Yeah. Alright, well, let's see how this goes. 91 to 9. This is much better. Cool. And that's just from, like, the same algorithm, but with slightly less wasted cycles. What would we have to do to always win? Is that even possible? I mean, it would be if you knew the shape of the network every time, perhaps. But it would be a bit difficult to even write that code. What occurs to me is that we have a disadvantage when we are placed near high-numbered links, right? Because our replicator starts at 2 and counts upward. What if we tried to even things out by having 2 replicators, one which counts up and one which counts down? So let's, how do I, can I like, okay, so this is macros, I guess is what this one represents. This one, let's just say, actually it's just the same, it's just bad macros. Bad macros. Okay, so we want to copy this and call this open-ended. Because we're going to make 2 X's here, not 3, 2. And we're going to skip this whole init business. But we're just going to change the order of things. 13 and minus 2. Starting at 7 and going minus 2. And I want these higher numbered ones first, then the middle ones, and then the move to 2. How does this do? Oh, I got everywhere. Look at that. 47 to 15. He still blocked that end off. No, we didn't lose game 5 anymore, which was a game we lost in the original version. Alright, 98 to 2. Which games did I lose? I gotta know. It's hard to tell though, right? Like, I don't have any particular improvements left in mind. I'm just wondering, like, what are the conditions necessary for this guy to beat us, this chump? Well, it's before 38. I mean, we can do a binary search this way, I guess. Sort of. So, like, is it 24? I don't know. We can't actually... Oh, it just tests them all in order. Alright, well, we're not going to be able to tell. Cool, though. Alright, let's listen to the lore about this. You still aren't saying anything in the chat room. Don't you think they might want to hear from you? There's nothing for me to say. I have a theory. You're enjoying it. You get to be this mysterious, silent presence. I understand the appeal. What? So are these guys talking about? You might have won this time, but we should rematch. Yeah, we just beat this guy. Sure. So, got him. That was a cool one. Several iterative improvements on the obvious approach to make it faster, and speed actually matters a lot when you're competing against another program like that. I don't think that we should start a new puzzle at this time. It could take quite a while, and I don't anticipate being able to necessarily finish it in a reasonable length video. Although I guess, tell you what we'll do is we'll just, we'll load it up and we'll have a look. Find new hosts by exploring and mapping a data phone network. I've collected a lot of data by now, but my understanding remains incomplete. No understanding is complete. Not yet. I need more processing power. Open networks are getting harder to come by. Luckily, someone's buying personal data phones. Everyone's buying personal data phones now. Thanks, consumer rat race. Let's get me onto those. So this looks a lot like the radio station is the first thing that occurs to me. And look at that, there's even a dialer at the end. Using your modem, yeah. Connect to each data phone so that Emperor 2 will have a list of valid phone numbers. Each data phone contains a list of the owner's contacts in file 200. The phone number of one of these data phones is in your host? What? Oh, I see. File 300 contains a phone number. It is the phone number of one of these 8 phones. Whereas all of the other phones have their phone number stored in at least one other phone. Right? I guess. In exactly one. In such a way that you can find them all without getting stuck in a loop. How nice. Yeah, So I guess the idea is we'll just dial a number and then follow it. And then it's sort of hard to see how you test all of the numbers of some other phone, right? Modem control at the direct level in the second episode of the zine. Wasn't that in the first episode already? Is there like new stuff about it in episode 2? Maybe not. No. Writing -1 dial hangs up. Can you read from it? Huh. Okay, well, whatever. Right, so my question then is, how I guess are we guaranteed that each phone contains exactly one relevant phone number except for the last one, which contains none? Or could it be the case that, say, one of these phones, the first one we connect to, has phone numbers for all of the others in it, and then the others just point to useless junk? Because if there's only one, we could for each phone we get into, we could start screaming numbers out over the global channel. And I was thinking maybe then, like, try to traverse link 800, and, like, if a different modem has picked up, then our EXA will be destroyed, and we won't need to transmit any more messages. It's just hard to tell, like, when have you successfully dialed another phone? Previously, we didn't care, because we knew we would always get a valid number. And we just replicated an EXA to go over there. And also the work we needed to do inside of each host was like, it didn't interfere at all with stuff we needed to do outside. Now we need some sort of two-way communication, which is much more difficult. In fact, even like, I don't know. I mean, we could broadcast all the messages. We could try dialing each of them, and each time spawn an EXA to go into another phone. But the trick is then, you might have multiple EXAs all screaming numbers at once. And that's what I don't know what to do about. Well, a problem for another time, I guess. Maybe you guys can come up with an answer before this next episode goes live. Thanks for watching, and I'll see you next time.